Hello there, here we go, chapter 1.3. This is one of my favorites. I'm talking about the properties of addition and multiplication. And the first property that we're going to talk about is the commutative property. Commutative property is an important one. And it's important to just kind of recognize the words that are in there. Commute. Commute is like the trip your parents take back and forth between home and work. And it's also the same thing that you take between home and school. You go there and then you go home. You go back and forth, and you kind of feels like you go every day sometimes. And that's your commute. And the commutative property is something that we have for both addition and multiplication. Okay, so this is something that we have for both, and I'll show you how easy it is. It's very simple. You know this is true. You might not have known it was called the commutative property. It's something that you need to learn. Remember, it's back and forth. Okay, and the idea is that they can change places. I seem to only like 3 colors. Here we have a number, say 12 plus 3. It's the same thing, and our commutative property shows us that it's the same thing as 3 plus 12. 12 plus 3 is 15, and 3 plus 12 is also 15. It doesn't matter if we change places. We can swap sides, and they end up equaling the same thing. For multiplication, same goes. 3 times 5 is the same thing as 5 times 3. They can go back and forth. 3 times 5 is 15, and 5 times 3 is also 15. And very simple to see. You flip places, it works very well. Now the opposite is not necessarily true, and this is where we get into some trouble sometimes. This is not true. 3 minus 1 is not, use a not equal sign, not the same thing as 1 minus 3. It doesn't work for subtraction. 3 take away 1 is 2, and that is not equal to 1 take away 3. We have a little bit of a hard time when we start with 1 and we try to take 3 away from it. It doesn't work. We actually get ourselves into negative numbers, something that you'll learn more about later. 2 is not the same as negative 2. 1 take away 3 doesn't work. If you start with 1 and you take 3 away from it, you get negative 2, and it's not the same thing as starting with 3 and taking 1 from it. Division is the same thing. This does not work. Let's start with 15 divided by 3. We had 3 times 5 is 15, so we're going to work backwards. Is not the same thing as 3 divided by 15. 15 divided by 3 is 5. You knew that. We already had that up here. 3 divided by 15 is 3/15. 3 divided by 15 is the same as 3 over 15. And if we simplify that down a little bit, that becomes 1/5. And 5 is not equal to 1/5. They're not the same thing. Division doesn't work the same way as multiplication. It works opposite, but you can't use these commutative properties when you're doing subtraction or when you're doing division. They work great when you're doing addition and multiplication. Let me show you real quickly with one of our positive colors a use for it. When you're adding, and you add 3 plus 5 plus 7. Now, this could be done any way you want to. You could add 3 plus 5, which is 8, and 8 plus 7 is equal to 15. But you could also change it around, and some of you are going to notice that this works really nicely for bigger numbers, so that you get something that's easy to work with. 3 plus 7 is 10. 10 plus 5 is 15. Works great. If you start with something more complicated, 22 plus 13 plus 48, it might be easier to change and put this 22 together with the 48 because the 2 and the 8 add up to a nice even 10. 22 plus 48 plus 13. That's a little bit nicer, and you can see that 20 plus 40 is 60, plus the 2 and the 8 make a 10, so that's 70. 70 plus 13 is equal to 83. And it might just be a little bit easier to do it this way than try to add the 22 and the 13 and then the 48. So you can change it around, make it work real nice. With multiplication, same kind of thing. You have 3 times 11 times 10. I don't know if it's actually easier. 3 times 11 is 33, and 33 times 10 is, remember we learned this a while back, you just add the 0, so it's 330. It might be easier in your own head to do the 11 times the 10 first and then multiply that by 3, or the 3 times the 10. If we try it that way, 3 times 10 times 11, what really happens here is 3 times 10 is 30. And 30 times 11, we're basically in the same boat. This one is maybe the best example. 30 times 11, well, 3 times 11 is 33. And we add the 0, we get 330 either way. This is that 0 that just got added onto the end. This problem isn't necessarily easier. I wonder if I can think of one that is. Put a little bar here to show us, and I'll try something else. Say, here we go, 4 times 9 times 25. Now if we just go 4 times 9, we get 36 times 25, and 36 times 25 is something we can do, but it's not super easy. If we change it around and we say 4 times 25, using the commutative property, just change this 9 and the 25 around. We get something that we can deal with, because 4 times 25 is sort of magic. That's 100. And 100 times 9 is 900. So that was actually easier by switching it around. There's a good example. We got some answers here. We got it all figured out. And we're happy campers. And we're going to stick our tongue out. There we go. Have a nice day.